Okay, the fourth question from the page 42. In the picture, a circle is drawn with a line as diameter and a smaller circle with half the line as diameter. Prove that any chord of the larger circle through the point where the circles meet is bisected by the smaller circle. Very interesting question. Okay, there are two circles. One is bigger and the other one is small. And there is a connection between the diameters of the circle. The smaller circle has the diameter half the bigger circle. Okay. Now we have to prove that these two circles are meeting at a point, and if we draw any chord, what is a chord? Chord is a line joining two points on the circle. Okay. So if we draw any chord through that particular point, if we draw any chord of the bigger circle ഒരു കോഡ് നമ്മൾ ആ പോയിന്റിലൂടെ ഡ്രോ ചെയ്യുകയാണെങ്കിൽ we have to prove that the small circle will bisect each of that chord. We have to prove that. Okay, let us move to the GeoGebra or application. Computer has a problem. Okay, here the figure is drawn. Two circles are there, a bigger one and a smaller one, and they are meeting at a particular point, and a chord from that point, a chord of the bigger circle is drawn. Okay, now let us find out let us try to prove the theorem. So let us mark the endpoints of the diameter A and B. So AB is the diameter of the bigger circle, and a chord through the A is drawn. So AB is the diameter of the bigger circle, and O is the center of this line AB. That is, O is the center of the circle. Okay. Now AD is the chord. AD is the chord that passing through the point A. This point A is the point of intersection of these two big circles. Okay, so a chord AD is drawn like this, and this chord is the small circle is cutting this chord at a particular point E. Okay, we have to prove that AE is equal to ED. We have to prove that the length of AE is equal to length of ED. Okay, for that, let us draw a line OE. And what about that angle, or what is the specialty of that particular line in connection with the line AD? It is perpendicular. That means the angle between them is 90 degree. Why it is so 90 degree? Because look at the small circle only. The small circle in the small circle, AO is the diameter, so the upper part is a semicircle, and E is a point on the semicircle, so that angle is always 90 degree. We have already learned that. So angle at E is 90 degree. Now let us draw or join the points B and D like this. DB, this is also 90 degree. Why? Because AB is the diameter of the big circle, so the upper part of that big circle is a semicircle, and D is the point on the semicircle, so that angle is also 90 degree. See here, the line OE is perpendicular to AD, and line DB is also perpendicular to AD. So if two lines are perpendicular to the same line, then we can say that perpendicular lines are mutually parallel. We have already learned that. A line and two lines are drawn perpendicular to it. Then these perpendicular lines are mutually parallel. So these two lines are parallel. Now watch this triangle ABD. A triangle is there, triangle ABD. In triangle ABD, DB is a line, is the side of this triangle. DB is the side of this triangle, and OE, the line OE is parallel to that side, and it is also going through the midpoint of another side. So in the 9th standard we have learned a fundamental theorem, that is, if in a triangle if a line is parallel to another side and it passes through the midpoint of the second side, then it will also bisect the third side. We have learned like that. In a triangle, if a line is parallel to one of the sides and it passes through the midpoint of the another side, then this line will bisect the third side. So this is the side of the triangle, and EO is the parallel line and which passes through the center of the second side of the triangle AB. Okay, so this line also will bisect the third side of the triangle, that is, the point E is the midpoint of the line AD. That means AE and ED are equal in length. So we have to prove that the small circle is always cutting the chord AD in two equal parts, or the small circle bisects the chord AD. We have to prove this one. Okay.